Hi, my name is Charlie Suazo, and this is my Physics 2-Lab 1. Here's just a quick overview of what we're going to talk about today. So, for an introduction to the lab, the purpose of this is to perform an experiment with two charged objects in order to observe their interactions. And then, based on these observations, we're going to draw conclusions and perform calculations to demonstrate equilibrium based on electrically charged objects and show electric fields. So, I'll talk about all the models and fundamental physics principles a little later, but here's kind of a preview of those that I'm going to talk about. And then here's an overview of our results. So this shows the computational model here, our results of our forces and charges. And then this shows my lab in action where the two tapes repelled each other. You can see this one's kind of pushed up a little bit. But quickly for some background information for the pre-experiment. So we were given in the lab directions that a pen rubbed against hair is negatively charged because it gains electrons from the hair because of friction. So since we knew that the pen was negatively charged, we used that knowledge to determine the charge of U-tape. And since the U-tapes attracted the pen, we found that they were opposite charges, which means that that the U-tape was positively charged, meaning there was an overall loss of electrons in the tape. Further physics principles, the most important equation is the Coulomb's law formula, which describes the force, the electric force, which is just 1 over 4 pi epsilon 0 times the charges over the radius between them squared. And this really is a vector value, so there should be a r hat here. But also we talked about gravitation, F equals mg, polarization of neutral objects, which was actually came up in the pre-experiment, where we also determined that charged objects attract neutral objects because they polarize. And then we also talk about electric fields, which is really what creates the force that attract and repel in electric charges. And then the derived charge formula, which is just a kind of reworking of the electric force formula. And then Newton's second law, which shows that in equilibrium, forces are equal and opposite. So since we only assume two forces, here you can see in the free body diagram that the electric force is pointing up, and that means the gravitational force was directly opposite, pointing down. And so our system overall is our top tape in the image I showed you before, and the surroundings of the bottom tape and Earth. And I predicted that the negatively charged U tapes would repel and that they would reach equilibrium with gravity. And we can see that my charge prediction was actually incorrect later on. So for the experiment, this shows me pushing one U tape against the other, and this one bowing up a little bit was repelled by it. So here are our constants. I'm not going to go over them to save time, but with these, we calculated the area of the tape, which was used to find the total number of atoms. And then skipping ahead up here a little bit, the total number of atoms was used to find, like with the charge here in this equation, to find the total number of electrons lost. And then from the force of gravity and electric force, based on the equations I provided earlier, and using the separation between the two, we found that the overall charge in the system was about 2.27 times 10 to the negative 8 coulombs, which is actually very close to what we got in our computational model, which I'll show after this. So here's the computational model. For this, we had to assume that there were only two forces, gravity and the electric force, acting on the two charges, and that there was no loss of charge from handling when you ripped up the tape, and also that they are just point particles interacting. And as well, furthermore, we also assume that the same charges were acting on both of the U tapes. And in terms of air resistance, we don't really need to ignore it or include it in any way because the tape is static. And here's the computational model. You can see I go over constants that I talked about earlier. This is the creation of the two spheres, which are our point charges and their locations. And then here are the force of gravity and the electric force acting on the system. And from the electric force, we used the derived charge formula, which is shown here, to find the charge on our U-tape. And these arrows are just creating arrows to show the free body diagram. And finally, for the discussion and conclusions. So with the model versus the predictions, we had almost the exact same charge calculated and almost the exact same forces calculated. But my original prediction was that the U-tape charge was positive or negative, but it actually ended up being positive. And then for sources of error, there were definitely some small rounding errors, which led to my differences in the charges calculated and forces calculated. But we could also find sources of error from the fact that the two tapes aren't point particles, but are actually distributed charges. And also, when you touch the tape with your hands and touch the tape to the book, this definitely neutralizes them a little bit, which decreases the separation distance that we found. So finally, what if and why questions. So for what if electrons had positive charge and protons have negative charge? What would the change be in the observation you made with your tapes and other charged objects? So if electrons had positive and protons had negative charge, this would basically not change much of the calculations overall because the U-tapes would actually still be repulsive as the charges are the same, but the overall charge would be negative instead of positive. And then, why is it important for you to handle the charged tapes as little as possible? What happens when the charged tapes come into contact with your hands and other objects? So it's very important to handle the charged tapes as little as possible because when you touch them, your body is more likely less charged than the tapes, so it's going to neutralize both those objects. So when the charged tapes come in contact with your hand, the electrons from your hand transfer to the tape, creating difference in charge that wouldn't be there otherwise. Thank you.